What you going to do therefore I told you not to swallow? That was Omphalotus. Now you got loose bowels. Hey guys, welcome back to the channel. I've been covering a lot of the goody compounds found in mushrooms, but today in class we want to touch on a toxin found in the jack-o'-lantern, aka Omphalotus mushrooms, and it's known as illudin, or I should say illudins, which is actually a class of these toxic compounds. These are a type of sesquiterpene found in the jack-o'-lantern mushrooms. Hey, let's check it out. Let's turn this camera over to my truck, get us started here. Hey, if you look in the reflection, you might even notice I got a little camera mount for the microphone and stuff now. So let's try this out. Rock on. All right, let's get started here. Illudin S. I'm only using this one because it's kind of the primary one that's being studied right now of these compounds. But they are, as I wrote up here, found in Omphalotus species, not just Illudins, which is the one found out in these woods, but even around the world, you'll find its cousins contain these compounds. Anyway, Illudin S looks very familiar to me, and I wondered why. Well, this is why. Let's march over here. I wrote down a few common compounds. You might recognize some of these names up here. Hey, there's my happy one right there. You guys know what caffeine is. Look at caffeine. Look at the structure here. Now jump over here. Man, very similar. It's because it all starts from this nitrogenous base, this purine right here. You see the nitrogen groups in here in this 5 ring, and the 6 ring has a couple nitrogens in there. Anyway, keep all this in mind, that this structural similarity gives caffeine its effects in our body. It's also the building block for these 2 nitrogenous bases found in DNA and RNA. So you probably heard of adenine and guanine back from biology class when you were learning about DNA. Well, this is how the toxicity comes into effect. Jumping back over, this nasty thing is an alkylating agent. That's one kind of agent of calamity you don't want to mess with. So when you eat jack-o'-lantern mushrooms, hey, back at me. When you eat jack-o'-lantern mushrooms, you're going to have a really bad time. And no, they're not going to kill you. But what they're going to do is they're going to disrupt certain processes inside your cell where your cells are replicating DNA constantly, because your body has to constantly replace the cells that's going on. So literally by the billions, all the time, constantly, you're having your DNA copied over and replaced, and cells are dividing and replacing themselves. That's normal processes here. What happens here, though, is they attach an alkyl group, like a methyl group, to guanine. Shoot, I almost forgot. Guanine is the one I wrote down because what it does is it through a chemical process intercellularly will attach 1, 2, 3, 4, 5, 6 to the 7 nitrogen right here. It'll attach a methyl group to this guanine, basically preventing it from, how do I explain this? Guanine is actually part of your DNA. And when it's methylated in the DNA sequence, it prevents the transcription or the copying of it over to, copying over to the RNA. So how do I explain this in simple terms? Imagine having a broken tooth on a zipper and now the zipper don't work. Okay? That's what this nasty thing does. So don't eat jack-o'-lantern mushrooms, but what is this thing? So researchers have modified this Illudin S alkylating agent molecule, as damaging as it is, and they've hypothesized and have been experimenting with taking derivatives of this. This one is an example here. This is irofulven. You see the similarity? They're actually going to take alkylating power and put it to good use. So if you know anything about cancer, cancer is when a cell doesn't know how to die. It just rapidly grows and replicates itself out of control. Well, they got the idea If this thing will disrupt DNA transcription and copying of DNA, well, what cells in the body do the most transcribing of DNA, the fastest replication? It's cancer cells. Cancer cells are very aggressive. They multiply very fast. So a drug that would attack DNA transcription and replication would be more toxic to a cancer cell than a healthy cell in the body. And that's the theory behind some of these anti-tumoral and anti-cancer drugs is let's go in and attack DNA replication or transcription, and hopefully the cancer cells get affected by it worse. Well, switching it back over here. Experimental anti-tumor drug. It's not an actual prescription drug as of yet. It's still in the trials. But I wrote this big long word down. For those that like big long words, let's read it together. We've got O6 methylguanine DNA methyltransferase. Here's its little abbreviation. I like to just call it the management enzyme. It's an enzyme. Remember, if it ends with ACE, it's saying what it's doing behind the ACE. So what is it doing? It's transferring the methyl from the methylguanine. Methylguanine was, remember we talked about it earlier, the guanine having that methyl group or the alkyl group attached to the 7 nitrogen spot. So this enzyme actually corrects, so it can actually go back to normal transcription. So this is the problem they're having in the anti-tumor drug research with this compound, is that this is stopping it from doing its job of killing off the cancer cells through stopping the DNA transcription. So what they're having to do is actually they're having to alkylate or methylate this enzyme. So by throwing like a wrench into the machine causes the machine to stop working, they're attaching a methyl group to this enzyme, causing this enzyme to not be able to do its job of cleaning up the DNA. That was a mouthful. I can't believe I got all that. Hey, if you want more of this crazy chemical or chemistry stuff dealing with mushrooms and how it plays out in the science and in the health side of things, don't forget to subscribe to this channel. Hey, if you learned something crazy, or if I made you even laugh for a little bit, go ahead and hit that like button. Thanks for watching this video. I'll see you next time. Peace.